These are the solutions to the centripetal force and acceleration practice questions. Right, question one. This is a really typical question. So centripetal acceleration, what is meant by that? This comes up almost every year. It's usually 3 marks in the exam. So this is based on the notes in the previous video. So 3 points would get you the 3 marks. So the idea of a change of direction. So there's a constant change of the object's velocity, and therefore there must be an acceleration. That will get you 1 mark. We need to identify the direction of the acceleration, the centripetal acceleration. That's towards the center of the circle. And then the third mark would be, well, why is there a force? Why is there acceleration? Well, there is an unbalanced force towards the center. So something will provide that. It might be tension or weight or electrostatic force. Something provides a force to the center. Therefore, according to Newton's second law, F equals ma, there must be an acceleration. So it's always a good idea to make reference to a law, or in this case, a formula, to make sure you get that mark. Question 2, basic calculations. You probably won't get one quite this straightforward in the exam, but the basic calculations are v squared over r. Well, we know the velocity and we know the radius. Watch out for kilometers, and we'll get an acceleration meters per second squared. And then if we're trying to find the force, well, it's just m times a. Once again, it's related to Newton's second law. We just multiply our previous value by the mass, which is 1/10 to the 4, or we just do the whole calculation again, mv squared over r, and we get our value in newtons. And very often we'll have to identify where the force comes from. So if you just say friction, that probably won't get a mark. We need to identify, well, where is the friction? And there's actually Newton's third law pair here, because we've got the friction between the tires and the road, which is caused by the steering wheel. And then the pair, the equal and opposite reaction force, is the friction between the road and the tires, which is pushing back in the opposite direction, which will be towards the center of the circle. Question 3 is a bit more tricky, and you might get something like this in the exam. So we're given the mass, we're given the radius of the Earth, and we're given a height. Well, that's really important. We need to combine those two together, as we will see. And we're also given a value of g at that height. So that's really important. The idea that gravity is not zero in space, which is a very common misunderstanding. If we're only 400 kilometers away from the surface of the Earth, then g will be slightly smaller, but it's certainly not zero. Okay, so we need to find the centripetal force. Very often students would struggle with this one because they think, right, mv squared over r, I don't know the velocity, and that's what I need to find for part B. So how do I do it? And they might struggle with that. So we need to identify, well, what is providing the centripetal force? That is provided by the weight of the satellite. So even though we cannot calculate at this stage mv squared over r, we do know m and we do know g at this height. So we've got to be careful here. We're so used to using g as 9.81, we'd have to remember to use the value given to us for g at that height. So we can calculate the weight, which is equal to the centripetal force. That provides the centripetal force. Okay, and then we can use this formula from centripetal force, rearrange to make v the subject. Now we have the force, and we know the mass. Be careful with the radius. Very common, students think, right, that's a radius. That must be the value that I use. The radius is going to be plus 400. So the satellite is not orbiting at a ground level. That would be very dangerous indeed. So it is orbiting at 6,800 kilometers, and we need to include the times 10 to the 3 multiplied by 1,000 to change kilometers into meters. And then square root of the whole thing, we get 7,380. So that is really fast. That is 7.4 kilometers per second. So this is a very typical satellite speed, especially in a low orbit such as the ISS. So if you get a value of satellite speed as 5 meters per second or something like that, you've probably made a mistake. Expect big numbers. Right, we're trying to find the time. Well, we've got constant velocity. We assume that it's a circular path. So v equals s over t. We're trying to find t. S over v. S is the circumference of the circle. So 2 pi r. Once again, watch out for our radius is 6,800 multiplied by 10 to the 3. Then divided by the previous value, and you'll get the time taken for one orbit. Exam tip here, as always, show all your working out, because if you made a mistake in part B, let's say you forgot to add on 400, so you got the wrong answer. If you showed all your working out, then you should get full marks for a wrong answer. And final question, part D, how many times it orbits the Earth each day? Well, there's no official formula for this. We just need to know that if I work out the seconds in one day, so 60 times 60 times 24, and divide by the time in seconds for one orbit, that will give me the number of orbits. So I think it's slightly less than 15, but we could round this to a whole number. Question 4. What provides the centripetal force? Now it says explain. Now if this is an exam question, we might need to add a bit more detail. So this is just state. So we've already mentioned if we have a satellite, the centripetal force is provided by the weight of the satellite. If we have an electron orbiting a nucleus in an atom, then that will be the electrostatic force, which acts towards the center. If we have a car cornering on a banked road, now we haven't studied this yet. We're going to look at this in the next video. You could say friction, but it won't just be friction. The purpose of banked roads, so this is the road at a bit of an angle of elevation, is that we have an additional help to get around the corner. And as we'll see next lesson, you can actually go around the corner without turning the wheels if the bank is sufficient. So we'll look at this in more detail next lesson. It's the horizontal component of the reaction force. So the normal force, the reaction force, is at 90 degrees to the slope. So the horizontal part of that, acting towards the center, will provide the centripetal force. And similarly with an aircraft banking, and again, we'll look at this in more detail next lesson. It's basically the same. It's the horizontal component, but now of the lift force. Question 5. So we have this vertical circle scenario, very, very typical situation. And we have a mass on a piece of string. What are the forces acting on the ball? Okay, so the forces acting on the ball, these will always be the same in this situation, the same type of force, not the same value. We always have a weight, mg, and that always acts downwards. And we will always have a tension acting towards the center of the circle. Now that will either be up or down depending on where we are. So if we're at the top, the tension acts downwards towards the center. If we're at the bottom, the tension acts upwards towards the center. So we identify the forces. There are only two forces. So question part B, they combine together to make the resultant force, and the name we give to that resultant force is the centripetal force. So that's really, really important. Sometimes students think that the centripetal force is an additional force, it's a third force. That's not true at all. It's the name we give to the resultant force of, in this case, the weight and the tension. So as we can see at the top, both of these forces are acting down. We have the weight plus the tension acting together. They combine to make the resultant force downwards, the centripetal force. At the bottom, however, it's different because the tension's acting upwards. So the tension take away the weight provides the centripetal force. So this leads us into part C. Where will the tension be largest? Hopefully you can see that will be at the bottom, because at the bottom the tension has two jobs to do. It has to balance the weight and also provide a resultant centripetal force. So T minus mg gives us the centripetal force. So T is going to be mv squared over r plus mg. That will be larger. Final question, following on from question 5. So this is calculation. So it can be useful to draw a diagram just to identify what's going on. But the first stage is always going to be, well, I suppose calculate whatever we can. But if we're given the mass and the radius and the speed, we can calculate mv squared over r. So that will be our first thing to do, and we get 192. We can also calculate the weight, mg, m times g, and that will give us 58.9. So following on from question 5, we can say that the tension at the top is mv squared over r minus mg, because we said that the centripetal force is equal to T plus mg. So we make T the subject. So all we need to do is to subtract the weight from the centripetal force, and we get 133. However, at the bottom, as we said, the tension is the sum of these two, because it has to provide both the centripetal force and balance the weight. So we're going to add these two together, and we get 251. So as we probably mentioned earlier on in this topic, the calculations, the maths involved in this topic are not particularly difficult, but a lot of students get really confused about what's going on with the weight and the tension and the centripetal force. So once we have these two values, we either add them together to get the bottom tension or subtract them to get the tension at the top. Part B, a slight variation. So in this case, we're told what the tension is, that's 360, but we're not told what the speed is. So that's the unknown value. So here we're given T and we don't know V. So once again, at the bottom, T is equal to mv squared over r plus mg. So we know T, we don't know V, so we can rearrange this to make V the subject and put all the numbers in. We've got 360 take away 58.9, multiplied by 2 divided by 6, all square root, and we get an answer of 10. So just be careful. If you get an answer, I think, of 11, then you have not included the weight. So that is incorrect. It's not a rounding error. It's actually wrong.